Hey guys, today we're going to talk about box plots. Now, box plot is a lot different from the last two things we've done. There's some of the data that we can find easier looking at a box plot, and then other data you can't find at all. So let's look at it and see what we need to know for this year and see how you can use this. And yes, people use box plots. I've seen them in magazines and stuff before, and I'm like, oh my gosh. It's kind of a weird one, but let's just go ahead and get going with it. So, a box plot only shows distribution of data, not individual numbers. If you remember yesterday, we were able to see how many kids said they had zero siblings and how many kids said they had two siblings. You won't be able to see that kind of data or individual grades that make up a grade on a report card. With a box plot, we won't see those numbers. Okay, box plots do not show mean or mode. We can see the range and we can see the median. We can see maximum and minimum very, very easily. Okay, the range or spread is the highest value minus the lowest value. We've already been talking about that. Now, here's a new word, and this word you'll only see when we're talking about box plots. It's called the inner quartile range. Okay, it's the inner range of data. So in box plots, everything is divided into fourths. If you can think about like a dollar bill is made up of four quarters, and two of those quarters is 50 cents, that would be 50% of the data. And so think about that. I'll refer back to that in just a little while, make a little bit more sense. So the median is the number in the middle. And it's really easy to see with box plots. So you have a little picture there and you can see the median right here. And then you can see these four boxes or four sections really. Only the middle is boxed. Those two middle boxes is the inner quartile. And then again, this used to be referred to as box and whiskers because it looks like a cat's whiskers. And so we just call it the box plot. So again, you can see it's kind of divided up into four parts. So we're going to read one. This could be pretty fast and pretty easy. So the median, I'm going to look right up here. It's this line and I come down and it's 22. That was easy. The range, I'm going to look at the top number, which is 28, and the lowest number, which is 16. I'm going to subtract them from one another and I will get the number 12. So that's my range. That was pretty fast and easy. The inner quartile range. All right, so this time I'm going to look at the 26. In fact, let me just go ahead and erase some of these other lines so you don't get confused. So here's the inner quartile range. Here's the highest number. Here's the lowest number. I don't know why that's doing that. There we go. So that's 26 minus 18, which is 8. That is my inner quartile range. The minimum is easy. It's right here. It's 16. The maximum right here, it's 28. Call those the whiskers. Now, between what numbers is 50% of the data? So again, we have everything in four sections. That inner quartile range is inner is 50% of the data. So we have, again, all this spread of the data. So between 18 and 26 is 50% of our data. That was pretty easy, right? Now, making box plots is not as easy, but reading them, it's pretty easy, pretty fast way to look at data. Now, when you can get a lot of information is when you're comparing data. So box plots are a quick way to compare data. So that's usually when you see it. If I see it in a magazine or something, that you're going to see two box plots and they're going to be comparing the data. So if right here, we have a box plot for the year 2000 and the box plot for the year 2010. I have no idea what the data is about. We're just going to go ahead and read the data. So it wants us to compare the median. So for 2000, I come on down here and it comes all the way down to 20. And for 210, I come down here and it goes to 17. So I'm comparing that data. Now I'm going to erase those two lines. The range for 2000, it starts at 27 and it, or 6 to 27. So that's going to be 27 minus 6. So the range for 2000 is 21. Now we're going to do the range for 2010. So let's see, the highest is 20. I'm sorry. The highest is 28. And the lowest is 8. So for 2010, the range is 20. So it has a greater range in 2000 than 2010. Okay, interquartile range. Now we're just going to look at the boxes in the middle. So for 2000, it's the highest number here is, I'm going to say that's 2120. We're going to say that's 20. What did I put in my notes? 23. So we'll go ahead and go with 23. It's kind of in the middle there, right? For the lower quartile, it's 14. So minus 14. So the interquartile range for 2000 is 9. All right, I'm going to erase that. 2010, the interquartile range starts at 20, 11. So it is 9. So the interquartile range is the same for both of them. Okay, which box plot has the lowest extreme? So let's see, for 2000, it is 6. For 2010, it's 8. I'm going to go ahead and erase my 6. And so the one with the lowest is going to be 2000. The highest, again, I'm going to erase that right over there. Let's see, the highest looks like 2010, which is out here at 28. And then the biggest spread. Well, we don't even have to do any work for that because we've already looked at the spread. The spread is the range. So if I look at the number 2 example or question, we put that 2000 because it has a 21 as its spread. It's pretty easy stuff, right? All right, it's your turn to practice. And so come ask questions if you need anything. Good luck. I'll see you later. Bye-bye.